For this, the FG for block B would be pointing down, and the tension would be pointing towards the middle of the string, and the tensions would be equal. And then the FG for block B would be larger than T because the line of motion is going downwards. And for block A, the FN would be pointing up, and it would be equal to the FG pointing down because they're opposite but equal. The net force for block B is equal to MA, and you would expand this by substituting it with FG of B minus T is equal to MA, because if you flatten the system, then FG is pointing right while T is pointing the opposite direction, and the net force for A would be MA, and the only force acting on block A is T, so T is equal to MA, and you would substitute the T from over here to the T to this equation, and then FGB would equal to mass times gravity, and then minus MA is equal to MA, and you add MA onto both sides to get mg is equal to 2ma. Then you cancel out the m on both sides. You get g is equal to 2a, and divide 2 on both sides to isolate for acceleration. And the acceleration is equal to g divided by 2. You would use the height is equal to 1/2 a t squared plus vi y times t. In this equation, viy is equal to 0 because there's no speed in the y direction, so you cancel it out. And it is acceleration instead of gravity, because the system has an acceleration which is g divided by 2 and not g. So you would isolate for t. By multiplying 2 onto both sides to get 2h. And then for a, you would substitute a as g over 2 times t squared, and then you multiply 2 and divide by g onto both sides, which is equal to 4h divided by g is equal to t squared. And then you square root both sides. And then square root of 4 is 2 times square root of h over the square root of g. And this is the time. For d, we can use the displacement formula as displacement is equal to 1/2 times a times t squared plus vi t. In this scenario, block A starts at rest, so there's no vi. So the x is equal to 1/2, and we use the a that we found earlier, which is g divided by 2. And we also use the time that we found earlier and plug it in. And then we simplify this as G divided by 4 times 4 H over G is equal to the displacement. And then we cancel out the G and 4. So the motion of block A would be H. The length of the surface for block A is 3H, and then we use the H that we found, and then we subtract H to get the motion of block A, how far it travels when block B strikes the floor and block A leaves. So block A travels a distance of 2H. For F, we use VF squared minus VI squared is equal to 2A times the distance. And then we solve for VF. We can also solve for VF by using VF is equal to VI plus AT. And then we use the VI would equal to 0. So VF is equal to 0 plus AT. And we use the A from earlier as G divided by 2. And we also use the time as 2 times square root of H over the square root of G. And we find VF as G times the square root of H over the square root of G. The 2's cancel out because 2 divided by 2 is 1. And then we find the time of when we find the time block A is in the sky by using height is equal to 1/2 GT squared. And there's no VI. There's no VIY for block A because the block A is on a surface before it free falls. And H we know is 2H is equal to 1/2. And then we use G for the gravity because it's free falling and gravity affects the system. We multiply 2 onto both sides to get 4H is equal to G times T squared. And we divide G on both sides to get T squared is equal to 4H over G. And then we square root both sides to isolate for the time, which is equal to 2 times rad H over rad G. And then we can find the range of block A by multiplying the VIX and multiplying it by the time, because the range only depends on the speed of the x direction and the time. So we plug in VIX as G times rad H over rad G and multiply by the time, which is equal to 2G H over G, and we cancel out the G's because it's both on the bottom and the top. So the range of block A would be 2H. To find tension, we can use the net force of block A as mass times acceleration and expand that as T is equal to ma. And then earlier we found A as G over 2. So we know that T is equal to mg over 2. So this is the tension. And for H, we can find a new acceleration by using the net force of B is equal to mass times acceleration, and we know Fg minus T is equal to ma. Then the new mass is, and the force acting on block A is T is equal to the new mass, which is 3m times A, and we can substitute T into the other equation and expand. So Fg is equal to mass times gravity minus 3ma is equal to ma, and you can add 3ma onto both sides. Yet mg is equal to 4ma, and you can cancel out the masses, which leaves you g is equal to 4a, and divide by 4 on both sides to get a is equal to g divided by 4. And using the new acceleration, we can plug it back into here to find the new tension. So T is equal to 3m times g over 4, which is equal to 3mg over 4. So this is the new tension compared to the old one. And 3 over 4 is bigger than 1/2, so when block A is multiplied to 3m, then the tension would increase. We know that the net force for block B is equal to ma, and splitting it up, we can determine that is Fg minus T is equal to ma, and we know from the force of block A, T is equal to ma. And expanding on this, the new mass for block B is 2m, so we can do 2m times g minus ma is equal to ma, and we can add ma onto both sides, which is 2mg is equal to 2ma, and we can cancel 2 and m on both sides, and then the new acceleration is a is equal to g. And then we can find the time for block A to travel when block B hits the ground using h is equal to 1/2 times acceleration times t squared. The a, we know a is equal to g, so we can plug that in. So 2h is equal to g times t squared, and divide g on both sides and square root to isolate for t. So t is equal to square root of 2h divided by g. And then we can find the displacement for block A. Block A is at rest, so there's no VI. And then A is G, so plug G in as A. And then we found the time earlier as radical 2h over G. Which is G over 2 times 2h over G. And we cancel out the G and the H, so the distance block A travels when block B hits the floor is h. And we can find the VF before the block A goes into free fall by using VF is equal to AT, and we can substitute AT as G, and we found the time as radical 2h over G. And the new VF would be G times radical 2h over G. And we can find the time of how far block A travels by using h is equal to 1/2 times gravity times the time squared, and then h would be, the height would be 2h is equal to 1/2 gt squared. And we can find time by multiplying 2 on both sides to get 4h is equal to g times t squared, and divide by g and square root both sides, and t is equal to 2 times rad h over rad g. And then the range formula is VIX times the time. And VIX we know is G times the square root to 2H divided by G. And the time is 2 rad H over rad G. And we multiply it out, so the square root of H cancels out, and the square root of G also cancels out. So it's equal to 2 times G times H and times radical 2. And then is over G. So the G cancels out. And then the new range would be 2 rad 2 H. And the student's claim is false because the range increases, but it doesn't double because it only multiplies by rad 2.